Hi everyone, so hope you're all doing well. So in today's video, I found this statistics question from the Edexcel AS 2022 first year exam. And I think this is quite a good question because it involves discrete random variables. And this part B is quite a tricky one. So we'll go through this today and hopefully this will help you out with discrete random variables and get you ready for the kind of stuff you'll be doing more of in year 30. But before we get into today's video, please do make sure you do click like and click subscribe. Click that like button, click subscribe. It really helps me out and it's free. It doesn't cost you anything and it takes you less than a second. So please do click those buttons and we'll get into today's video now. So the question says this. So Manon has two bias spinners, one red, one green. R is the discrete random variable which represents the score when the red spinner is spun. So if we look at this table here, when the red spinner is spun, we can get a 2 or a 3. So this little r there is our outcome. So in stats, little lowercase letters represent outcome. So we get an outcome of 2 or 3. So the red spinner has only 2 or 3 on that spinner. And we've got the probabilities there. So probability of a quarter of getting 2 and probability of 3/4 of getting 3 on that red spinner. And then G is the random variable representing what we get when we spin the green spinner. So the green spinner has, again, two numbers, 1 and 4 on it. So imagine you've got a spinner, which is green, and it's got two numbers, 1 and 4 on it. So we've got a 2/3 chance we get number 1 on that spinner, and we've got a 1/3 chance getting the number 4. So that's kind of what the table, well, both tables is showing us. So Manon spins the spinner once, spins each spinner once, and adds the two scores together. So we want to find the probability that the sum of the two scores is 7. Okay, so we'll start with this one. So I'll just write part A down here. So what we're going to do is add the two scores. So we're going to spin the red spinner, spin the green spinner, add the two scores and see what we get. So I guess a good way to do this is to do like a little table, like a little two-way table. So put red here, green here. And the scores we can get when we spin the red one, we can get a 2. Or alternatively, we can get 3. Or on the green one, we can get a 1, or we can get a 4. So we can do like a little table like this. And we're going to add our results together. So I just put a little plus sign here just to make it clear that we're adding the results. So when we spin the red spinner, if we get 2, and if we spin the green one and get 1, when we add those scores up, we get 3. This one here, obviously going to be 4. 2 plus 4 is 6. 3 plus 4 is 7. So we want to work out the probability of the sum. So essentially, one way we could write this, actually, instead of just writing this in words, we could say we want to find the probability that R, the red random variable, plus G, the green random variable, sorry, let me get rid of that bracket there, is equal to 7. So you want to find the probability that the sum of the R variable and the G variable is equal to 7. And that's the same as the probability of the red spinner being equal to 3, because to get a number 7, to get a sum equal to 7, we need to get 3 on the red spinner and 4 on the green spinner. So just do this in a different color just to make it clear. We want to get a number 7, so we need 3 on the red spinner and we need 4 on the green one. Okay, so we'll just add this in. So we want red to be equal to 3, and instead of writing the word and, I'm going to use this intersection symbol because technically and intersection are the same thing as in probability. So we want red to be 3, intersection with the green variable to be 4. That's how we're going to get a sum of 7. So the probability that we get 3 on the red spinner, let's go back to our tables. So probability that we get 3 on the red spinner is 3/4, as we can see that. So it's going to be 3/4. And the probability that we get 4 on the green spinner is 1/3. So we're going to times that by 1/3. And we're multiplying it because we want the probability of getting 3 on red and getting 4 on green. So when we want to find a probability of something and something, if they're independent, we just times them together. I mean, to be fair, the question here doesn't mention that they are independent, but I mean, they are. If you spin two separate spinners, common sense tells you that the outcome of one spin is not going to affect the outcome of the other one. So they are independent. So we can just times the probabilities here together. So 3 over 4 times 1 over 3, top times top is 3, bottom times bottom is 12. So we're going to get 1 over 4. So we get a quarter for that first probability. So that's question part A, part 1 done. Part 2, so we want to find the probability that the sum of the two scores is less than 4. So actually we can go back to our little table that we did here. Let me just rub out the red tick and the red circle here. So we want to find the probability that we get a score when we add, again, adding the two spinners, we get a score less than 4. So let's circle. So we've got 4 possibilities. We get a sum of 3, we get a sum of 4, sum of 6, sum of 7. So how many of these scores are less than 4? Well, obviously the number 3 is less than 4. Now 4 is not less than 4. Obviously 4 is equal to 4, but it's not less than 4. So actually, if we spin the red spinner, spin the green spinner, the only way we can get a sum of scores less than 3 is if we get 2 on the red one and 1 on the green one. So let's just write this down in the next part of the question. So part 2, which I'll write down here. So for the sum to be less than 4, so in other words, if R plus G is less than 4, we need the R to be 2 and we need the green to be 1. Okay, so the probability that R plus G is less than 4 is exactly the same as the probability that R is equal to 2 and green is equal to 1, as we can see from our table in blue there. So what is the probability that we get 2 on the red one? Well, let's go back to the question in the tables. So probability of getting 2 on the red spin is 1 over 4. So we'll write this down here. So it's 1 over 4. And then again, they're independent, the spinners. So we're going to times that by the probability we get 1 on the green one, which is 2 over 3. Okay, times by 2 over 3. Top times top will give us 2. Bottom times bottom will give us 12. So we're going to get 1 over 6 as our probability for part 2. Okay, great. So that's that question done. So now then, this is the tricky part. So we've got a new random variable, which is called x. And x is equal to m times r plus n times g, where m and n are integers. So we've got 2 random numbers that we don't know. Well, I shouldn't really say random numbers because we're doing probability here. So random means a random variable, but you know what I mean. We got 2 numbers, m and n, and we're going to multiply m by this random variable r and n by this random variable g. We're going to add them together and we get this new random variable x. So we've got 2 probabilities here. So we've got the probability that x equal to 20 is 1 over 6, and we've got the probability that x equal to 50 is 1 over 4. So we actually want to find m, a value of m and a value of n. Okay, so how could we do this? I guess one way to start would be to actually, instead of writing an x there and an x there, let's just actually substitute in this expression there. So we'll do this down here. So part B. So we know that x is equal to n times, I forgot which variable it was. It was r, yeah, n times r plus m times g. And again, I'll just check if I got that the right way around. Yeah. Oh, sorry, no, that's wrong. That's an m there, sorry. And that's an n there. Okay, so we've got the first probability, which is the probability that x equal 20. So in other words, the probability that m r plus n g, sorry, I should have forgot to put the equal sign here, is equal to 20. And we know that that is equal to 1 over 6. Okay, so we've got 1 over 6 here. And then the next one was the probability that x is equal to 50. So again, m r. So the probability that m r plus n g is equal to 50. And that was 1 over 4. As we can see, scroll again back here, 1 over 4. Okay, so what could we do now then? So the key with this question is to kind of use our result in part A to help us out. So there must, well, I mean, I say there must be, there doesn't have to be, but generally with these questions in A-level maths or any maths exam really you do, there's normally a reason why they've made you do part A of the question. And we're actually going to need to use part A to help us out with this question here. So we know from part A that the probability that we get the red spinner giving us the number 3, as we can see here, and the green spinner giving us 4 was 1/4. But that probability is exactly the same as this probability here, this probability of MR plus NG being 50. So what I'm going to do is just write a little sentence here. So we know from part A that the probability that we get on the which one was it again? So on the red spinner we get the number 3. So on the red spinner we get 3, and on the green spinner we get 4, is actually equal to 1/4. But that is exactly the same as this probability in this part B that we're given in this question here. So this is exactly the same as this MR plus NG is equal to 50 probability. So what does that tell us? So it tells us that when MR plus NG is equal to 50, it tells us that R must be 3 and G must be 4, because we know from part A that the probability that we get a red spinner giving us 3 and the green spinner giving us 4 is 1/4. Because that's exactly the same as this new random variable being equal to 50, it means that R is 3 and G is 4 in this case here. So let's make a note of this here. So this tells us, sorry, let me rub this out here. So this tells us that when this MR plus NG is equal to 50, it means that R is 3 and G is 4. So therefore we can say, if R is 3, we've got 3 times M there, so 3 times M, and then plus G, which is 4 times the N, so 4M is equal to 50. Just by combining this with that into one equation, substituting the R equals 3M, substituting the G equals 4M, we get this equation there. So we get this. So you've probably guessed it by now. It's going to be a simultaneous equation question, really, this one. And then again, we're going to do the same thing with this equation. Recognize that this probability here is exactly the same as this probability there. So again, we can do a similar little thing. So again, let's just write a sentence. So we also, sorry, let me try and make my handwriting a little bit neater because it is really messy today. We also know that the probability, so let's go back to the part A of the question again. So we know that the probability that of getting 2 on the red one and 1 on the green one is equal to 1/6. Let's just write this down here. So probability we get 2 on the red one and 1 on the green one is equal to 1/6. But that's exactly the same as our new probability in our question here, this one here, the probability that MR plus NG is equal to 20. So probability that MR plus NG is equal to 20. Now, just a little note, because I just want to be clear with this. So the capital letters in statistics, in probability, represent random variables, random numbers, okay? Now, I know that in this first half, this calculation, let me just color this in red. So like this calculation we did here, we said that red was 3, that the R was 3 and the G was 4. Now that doesn't mean that here the R is 3 and the G is 4, okay? That's not correct. Capital R and capital G are random numbers, so they can change, right? Depending on, when you spin the spinner, literally when you spin the spinner, you're going to get different numbers, right? In this red thing that I've just squiggled here in red, in this situation, what this is telling us is that we got 3 on the red spinner and 4 on the green spinner, right, in this particular scenario here. But in this new scenario down here, the number we get on the red spin and the number we get on the green spin is going to be different. So we just got to be careful that capital letters in stats are not fixed numbers, they're random numbers, so they can change depending on like when you spin the spinner. So in this case, if we go to this equation that you got here, this new one, so the probability that we get 2 on the red one, 1 on the green one is 1/6. But that's also the same as the probability that we get this MR plus NG is equal to 20. So what we can say from here is that when MR plus NG is equal to 20, this means that R is 2, as we can see here, and it means that G is 1. So again, we can do a similar calculation to what we did here. So therefore, MR plus NG is equal to, so in this case, R is 2. So 2 times M plus 1 times G, so that's just N. Sorry, 1 times N, because the G is N, the G is 1, sorry. So 1 times N, which is M, is equal to, in this case, 20. So you get this second equation there. So you got this first one there, we got this second one there. So we got a simultaneous equation. So let's just write them on top of each other like this. We got 3M plus 4N is equal to 50. And we've got 2M plus N is equal to 20. So it's up to you how you like to solve your simultaneous equations. So we could do like the GCSE method where we kind of multiply one of the equations by a number and then take away that equation. I mean, let's just do that here, for example. So what we can do is if we times number 2 by 4, so this number 2 equation by 4, what we'll get is we'll get 8M plus 4N is equal to 4 times 20, which is 80. And then we've obviously got this first one again, this number 1 equation, which is 3M plus 4M is equal to 50. So what I just did here is try and make the coefficients of N the same, because now we've got the same coefficients of M there, 4, which is our new coefficient of M. So if we then do the top one, take away the bottom one, so just put like a minus sign here. 8M take away 3M is 5M. 4N take away 4N is 0, and that's equal to 80 take away 50, which is 30. So divide both sides by 5. We know that M is going to be 6, and therefore we can plug this into like one of these equations here. It doesn't matter which one. Let's go with number 2. So sub M equals 6 into number 2, and then we get 2 times 6. 2 times M, 2 times 6, plus N is equal to 20. 2 times 6 is 12. 12 plus N is 20. So therefore, that tells us that N must be the number 8, because 20 take away 12 is 8. Brilliant. Yeah, so we've got M is 6, N is 8, and that is how we would answer that question. So yeah, any questions, do drop them in the comments below, but hopefully that was useful to go through how we would deal with a discrete random variable question, especially involving simultaneous equations. So again, any questions, do leave them in the comment section below, and hopefully it was useful to go through this question here today. If you are interested in having an online maths tutor for either A-level maths or GCSE maths, please do email me, because I am available to help out. So my email is drdifferentiation@gmail.com. So just drop me an email, just drop me some details about you, whether you're doing A-level maths, GCSE maths, and if there's any specific areas of maths that you need help with. So drop me an email, or get your parents to drop me an email, and then we can discuss everything about price, etc., etc. So drop me an email and we can get sessions booked in.